Okay, so in this video, we're going to look at congruent triangles. I'm going to define it and then do a bunch of examples. Okay, so first thing, congruent triangles are figures that have corresponding angles and corresponding sides congruent. So they are the same shape and the same size. When we do congruent triangles, we can define it with a congruent statement. And this is an example of congruent statement. So it's naming the one triangle, and then it's naming the other triangle, but you have to match it up. So here, like XY is the same as ST, because XY is first and then ST is first in the second statement. Like YZ here is the same as TR, because they're both the second and third. And so like angle X is the same as angle S, because they're both first. Angle Y is the same as angle T, and you can tell it from the picture, but they're not always drawn to scale. And angle Z is the same as angle R. So you might have to rely on the similarity statement. So they have three pairs of congruent angles. It would be angle X is congruent to angle S. Angle Y is congruent to angle T. And angle Z is congruent to angle R. And then it has three pairs of congruent sides. XY is congruent to ST. YZ is congruent to TR, and then XZ is congruent to SR. Okay, and this should match up with your similarity statement and also with your diagram. So there are 5 ways to prove triangles congruent. The largest side of the triangle is always opposite the largest angle. The smallest side is the triangle is opposite the smallest angle, and the middle side is opposite the middle angle. Because of this unique relationship, we can determine if triangles are congruent in the following ways. So side, side, side means all 3 sides of 2 triangles are congruent, then the triangles are congruent. Okay, so they're going to mark that with tick marks that the 3 pairs of sides are congruent. So that's side, side, side. Okay, side, angle, side looks like where you have 2 pairs of congruent sides and an included angle. So the angle has to be directly between those 2 pairs of congruent sides. It can't be here because that's not between the congruent sides. It can't be here. Okay, so that's side, angle, side. Then we have angle, included side, angle. Okay, so we have an angle, another angle, and then it's the side directly in between those 2 angles. That would be congruent. Okay, this is side, angle, side. It looks like that. Now, then we have angle, angle, unincluded side. So it's if an angle, another angle, and an unincluded side of 2 triangles are congruent, then they are congruent. So this looks like, okay, so we have an angle, another angle, angle, another angle. And then I'm not going to have this side that's directly in between them. I'm going to have the other side. So it could have been this side, it could have been this one, but it has to be a non-included side, which means it's not directly between the angles. And then the last one is hypotenuse leg. This is kind of a special choice for right triangles. If you have a right triangle, right, hypotenuse leg is that the hypotenuse of the 2 triangles are congruent and then one of the legs. And again, it has to be a 90-degree triangle. So this would be HL. So those are the 5 ways. Just to note, there are ways that don't work. So angle, angle, or angle, angle, angle don't work. It's not enough information. The 2 triangles could technically be, you'll learn about this next, similar. So they could be the same shape, but different sizes. So they're not congruent. So angle, angle doesn't work, even if they look congruent. If they only have 2 pairs of angles marked congruent, doesn't work. And then angle, side, side, or side, side, angle. So just note, angle, side, side spells a bad word. You can remember that that's the one that doesn't work, or if it spells it backwards. So what this looks like is if you have 2 sides and a non-included side are congruent, it's not enough information, not enough to prove the triangles are congruent. You can technically have either an obtuse or an acute triangle when that happens. The exception is if you have a right triangle then it's HL. So what this looks like is if I have a side, another side, and then an angle that's not directly in between them, this is not possible. It's not enough information to tell if they are congruent or not. Right? Unless again, if it's the right angle, like HL is technically the angle side, but if it's a right angle, that's enough for HL. Okay, so what we're gonna do is a few examples. We're gonna identify which congruent theorem applies to each and then write the congruent statement. So we're gonna figure out, are they similar? So this one has tick marks, which means sides. I have AB is equal to EF, AC is equal to DF, and BC is equal to DE, and so that's 3 sides. So this is side, and then the statement would be A, B, C, and the first order doesn't matter, it just matters that you match this up. Okay, A is between 1 and 2 tick marks, and so that matches up with F, because that's between 1 and 2 tick marks. B is between 1 and 3, so is E, and then D is the last one between 2 and 3, just like C. Okay, so this is side. Okay, this one, I have an angle, I have another angle, I have the side directly between those 2 angles, so this is side angle side. And it's triangle ABC is congruent to, okay, you could go 2 different ways. A has to go with Y, and then because they are isosceles, it really doesn't matter if you say X goes with B or Z goes with B, either way is right, so I'll just put XZ. Or you could do triangle YZX just because the angles are the same. Okay, this one, now they have this shared side EG, so we can mark that congruent. And then this one is I have a side, I have an angle, and then I have another side. So that angle's directly between those 2 sides. So this is side angle side. And I have triangle EFG is congruent to triangle. Okay, so I have to be careful. This E does not go with this E because this one doesn't have a mark on it. So I'm going to find what doesn't have a mark over here and is between the 2 mark and nothing. And so that would be here G. Okay, it doesn't have a mark and it's between the 2 mark and nothing. Then F is between the no mark and 1 mark. So that would be H. And then this G with this mark here goes with that E. Okay. And sometimes for students, like drawing them separate helps. So if you can't see it, like some people can like naturally see this and other people are like, I can't see it at all. So you could redraw them and then it might be a little bit easier to say like, okay, G has 1 mark, it's between the 2 tick marks and the 1 tick mark. I'm gonna put the 2 marks here. And then E is also has 1 mark and between the 1 and the 2. So that might help with matching it up. Okay, so this one, I can mark the share side. Now, if I did this one, it would be like, okay, here's angle, here's a side, here's a side. It's the not included, the angle's not in between the 2 sides. So it's technically angle side, but if you get that and it's a right triangle, which it is, then you need to check for HL. And so I do have the hypotenuse of both triangles and a leg. So this is HL. And then a triangle ABC is congruent to triangle. Okay, and again, you could redraw them. Okay, so A here is between the 1 and 2 check marks. Okay, that's not A here, it's C between the 1 and 2 check marks. Then I go to B, so I'm doing this triangle, which is on nothing. So C goes to D, there's no check marks. And then we go from C to B, which is along that hypotenuse, or sorry, B to C, which is along this leg. And that would be the same thing as D to A. Okay. And then this last one is we have a side, an angle, and an angle, okay? And so remember, you either have angle, angle, side, or angle, side, angle. And if you look, this side is not right between the two angles. So this is angle, angle, side, angle, angle, side. Okay, or side, angle, angle is the same thing. And the congruent statement would be A, B, C is congruent. This one's a little bit easier to see. So A goes with E, B goes with D, and C goes with C. Okay, so those are examples of applying those theorems.